So, we're almost there. Our final presentation this afternoon is Christian Hentschel from the Harald Hasso Plattner Institute for IT Systems Engineering at the University of Potsdam, joint project with the FITS Karlsruhe and Karlsruhe Institute of Technology in Karlsruhe. He'll be speaking with us about automation and standardization of semantic video annotations, which is a topic which has come up at SWIB several times, in this case for large-scale empirical film studies. So, welcome.
Yeah. Thank you very much. Thank you very much for staying here so long. I promise I try to make this as entertaining as possible. So I'm going to talk about movies, so you see a little bit of movie snippets and colorful images. So yeah, to make this last presentation for the day not too boring for you guys. So yes, as you said already, I'm going to talk about automation and standardization for semantic video annotations for large-scale empirical film studies. I need to give you a brief overview about the project that we're working on, just to give you an idea of why we're doing and what we're doing. So we are an interdisciplinary research initiative of researchers from the film scientists from the Free University of Berlin and computer scientists from us, from Hasso Plattner Institute, and Olivier Aubert from University of Nantes. And so the idea, so the task is we're doing research on audiovisual rhetorics by means of film analysis. What this means, I'm going to explain a little bit more detail in the following seconds. So the film scientists have been analyzing movies or videos in general for a long time already, and their hypothesis is that there are audiovisual staging patterns within a movie that cause a specific emotion within viewers. And they want to ground this assumption by means of annotations of those staging patterns within the movie. So what they essentially do is they annotate at large scale movies on a very high, very fine grade, very detailed level. And the guiding research question within the project is of how audiovisual images shape emotional attitudes towards a certain topic. And this requires the identification of an initial set of audiovisual rhetorical figures, which is done by the film scientists. And what we are doing is we're developing computational methods for the study of audiovisual rhetorics. So this is what I'm going to talk about now. We're doing this, we're analyzing these research questions on the subject matter of the films about the financial crisis. So feature films, documentaries, and TV news reports that have been published in the years 2007 and ongoing. So far, the film scientists have collected about 100 hours of movie data, which still excludes the news documentaries. They are still in the process of reviewing what they actually should include. Okay, so again, the motivation is we want to identify, localize, and classify audiovisual staging patterns. As I said, many annotations are necessary for a scientific and holistic understanding of a movie. And this poses a number of technological requirements, of which I will elaborate a bit more on two of them in the following minutes, which is consistent data management, which is most important for this audience here, and support for semi-automatic annotation data generation. I should have put a small disclaimer in front of my presentation. My background is computer vision and machine learning, so I'm not necessarily the best fit for presenting what we've been doing here. At least when it comes to linked data, to the linked data part. However, my colleague Henning Agt-Rickauer, who's doing most of the work on it, couldn't manage it, so yeah, I guess you have to deal with it. I do my very best, I can promise. Okay, let's start with the task of consistent data management. We're here on the Semantic Web conference. Obviously, we're doing this with linked open data. As I said, the film scientists have been analyzing movies for a long time already, so they developed a film analytical method, which they call Emacs, the Emacs annotation routine. It is systematic, so it has categories, types, and values. It also has a controlled vocabulary, which is, however, not machine readable, and most of all, although the vocabulary is controlled, they never had the possibility to control whether the annotators actually were using the vocabulary or not. So it's up to now, their annotations were mostly free text, so I don't have to tell you much about the problems which come along with free text annotations. So you have natural language, you have typos, you have all kinds of problems that come from synonyms and spellings. Yeah, for example, we had the problem that British English and American English was very often confused or used both at the same time. So our first goal was to generate a reusable explicit vocabulary with film analytical concepts, terms, and descriptions, which should be accessible on the web. And as a further problem, it should also integrate into the video annotation software that the guys are using, the film scientists are using. They're using Advene. Advene is you can see a screenshot on the right-hand side. So this is a track-based video annotation software developed by Olivier Aubert. I mentioned this before. So it has multiple tracks, each of which has a specific annotation type or covers a specific annotation type, and you can annotate a video time-based with the according values that you want to annotate. And Henning and Olivier did a great job of integrating our ontology into this annotation software. So from now on, when the film scientists are using their vocabulary, we can actually make sure that they are controlling that they use the controlled vocabulary. Yeah, so this is just maybe too obvious for you guys. Obviously, we use unique identifiers for domain-specific concept and terms. So you see here how an annotation type would look like. So we have the URL, we have a version, and we have a unique name. We can assign labels in English and German, and we can also assign a English and German description. We store all information, all annotations as RDF. So Advene has a support to export annotations as RDF. We put everything in a triple store. So, and I show you what we can do with it afterwards in a bit. This is what the ontology looks like. Of course, we have the domain experts from film science. We have 9 annotation levels. So this is according to the annotation routine, right? So we just modeled the ontology based on the routine that I've been using for a long time already. So we have 9 different annotation levels, 78 annotation types, and a total of 435 annotation values. You can download the ontology in our public GitHub repository. In order to make it a bit more graspable for the domain experts to use the ontology, or to understand what this is about, we developed a small application. And if this wouldn't be Internet Explorer, then you would be able to see a bit more than you actually can see. So this is the ontology. If you hover over one of those annotation types, you get the description in English. You can expand the annotation types to see the annotation levels. Sorry, to see the underlying annotation types. And again, if you hover, you get the description. So this is for them to verify that we have the same understanding of their annotation routine in our ontology. Okay. Let's go back to the presentation. Okay, so and this is an example of an annotation using our ontology. So we're falling back on common standards. So we use W3C web annotation standard for annotation target and annotation body definition. The body is actually based on our ontology, and we use media fragments to locate and identify specific segment within a video. This is an example for an annotation of the type tracking shot. So tracking shot is when the camera follows an object within a specific scene. At the moment, out of our entire corpus, we have one movie completely annotated according to the standards, which is Company Man, typical Hollywood movie on the financial crisis, about 2 hours long. They generated about 24,000 annotations, and this has been done mostly manual. Tremendous work. So we publish this. We want to publish this valuable data by means of linked data. It is actually accessible via our, again, in our GitHub repository and on our Sparkle endpoint. Yeah, as I said, we have Adrien supports our by now RDF export. I mentioned the web annotation standard and the media fragments URIs that we apply, that we rely on. As you can see here, this is the table for the annotation types mostly used. So the mostly used one is color range, which is simply an enumeration of the most dominant colors within a specific segment of the video. So whether it's more reddish or more bluish or more dark or more, black, and have an example later on. Yeah, and now that we have all this data, we want to make use of it, obviously, right? We don't want to just put it in a silo and then forget about it. We have developed 2 little demos. Unfortunately, I can't show them to you because, again, I believe this is an issue with the Internet Explorer, but you can actually, I'm not sure I put the URLs in here. So obviously, we want to query for specific staging patterns. So this is the most obvious application. So we want to combine specific annotation values and want to retrieve shots that have been annotated with this combination of annotations. So here's the URL. I can show you quickly what it would look like. So this is the Annotation Inspector, and if you would click on Annotation Query, then you would have to select the movie. In future, we want to do this corpus-wide. For the moment, since we only have a single movie, we can just, the corpus consists only of a single movie. And then you would select individual annotation types, which I can't select for the moment. I believe this is due to Internet Explorer. On my Firefox it works. And then you would select a specific annotation value, and then you can combine multiple of those, query them, and then the interface would depict you shots running in an endless loop of the results that have been found in our triple store. So this is based on the Virtuoso endpoint. Okay. Yeah, so this is what it would look like if it would work. So here I have queried for the image content person. So this is an annotation of the depicted concepts, the depicted objects and subjects within a scene, within a segment, and I've combined it with the body language emotion annotation, which annotates as it suggests the body language. In this case, I've queried for persons who look surprised, and if I could show you the demo, you could see actually that these 4 short snippets would show surprised persons. Okay, so far for the annotation schema, for the annotation ontology. I would now switch to a slightly different topic, which is the support for semi-automatic annotation and data generation. As I said already, huge amounts of annotations are necessary and are generated. So Companyman, the example that I showed you, has more than 24,000 annotations. I once asked the film scientists how long it takes them to annotate, and they assume that for 3 minutes of video, they require 10 to 12 hours of manual annotation. And if we have a corpus of 100 hours plus, and our project is only 4 years long, then you see that we have a scaling issue. So we cannot, even if they would, if we would force them to work 24/7, then they wouldn't manage. And second, this is obviously also error prone. Even if we have a controlled vocabulary, you can easily imagine, as on the example for example, what I showed you about the color range. Annotating a segment based on the most prominent color is highly subjective, so 3 people might come to 3 completely different colors depending on the palette that you're using. So what we wanted to do is we want to make a computer summarize the contents to some syntactical extent by extracting low-level visual features, and we hope that by this means we can increase the speed of the video annotation process. Currently, we're looking at the 2 modalities of a video, which is the audio stream and the video stream. And in the following, I will give you 3 different examples of what we've been doing in the past. One example comes from the video stream, from visual stream, which is the shot duration. Another is the example on the color range, which I've showed you before. And the last one comes from the audio stream, which is the dialog text. Let's start with the shot duration. Not sure whether most of you are aware of what a shot is. So essentially, shot in a video is the result of an editing process. So you take two segments of a video, glue them together, and those two segments would then be two shots. And the transition in between is called the shot boundary. There are different types of shot boundaries. Very typical ones are hard cuts. So one shot ends and another one starts. And then you have soft cuts, which just where you have some kind of transition between the individual shots, such as wipes and fades. And when you're able to detect those transitions, detect those shot boundaries, then you would be able, obviously, to count the number of milliseconds between two consecutive shot boundaries, and then you can annotate the shot with the sequence length. Okay, so this is done by means of temporal video segmentation, structure segmentation. So essentially, we group consecutive frames based on visual continuity and aggregate those two shots. So the idea here is, as I said, whenever two consecutive frames differ significantly enough from each other, then you could assume that the contents has changed so much that you should put a shot boundary there. So this is just roughly speaking of how this algorithm works. We are able to identify those two types, hard cuts and soft cuts, fades and wipes. And we're actually also robust to dropouts, which is not so important for this project here, because usually the material that we have is quite, the quality is quite good. Okay, let's come to the example of the color range descriptor. As I said, this is a simplified notation of the color range that is used in a sequence. Colors have to be picked from a restricted palette, so the annotators are presented a number of colors that they should assign, based on which they should decide whether the color is present or not in a shot. And from computer vision perspective, this has high automation potential, simply because we can easily automatically quantize all colors in the shot according to the most similar color from palette. You simply compute the Euclidean distance between the color values of a palette and the pixels in the frame and find the nearest neighbors, and then you're mostly done. We're doing this in a color space which is built according to the human visual system. So the idea here is that colors that are perceived similarly by a human should also have a lower distance in Euclidean space, whereas colors that are perceived as dissimilar should be located more distantly in this color space. And if we do this, as for example on this frame, then you can see, I hope you can see that it looks quite all right. And if we match this with the ground truth annotation, so below you see the annotations that have been made by the film scientists. On the right-hand side, you see our predictions with the probabilities. And you see that we agree on two of the made annotations already, and the other ones, you could question, for example, whether blue is actually a dominant color in this shot, or whether it's actually a salient color. So here we still have the problem of human annotators not necessarily agree on what is a dominant color in a shot. And they have also a high bias, a high expectation. So for example, you could say, is this wall in the background actually white or whitish, or do you only assume it is whitish because usually wall colors are white? We're still evaluating this and trying to improve this approach a little bit, but so far we're quite happy about the results. Last but not least, here's an example from the audio stream. So the film scientists also describe the spoken word, so everything which is spoken word. So we ignore nonverbal utterances such as laughing, coughing, stuttering, and so on, and they just transcribe this manually into searchable, machine-readable text. And this is obviously something which could also be done automatically by means of automatic speech recognition. You might ask whether we're actually doing this, why don't we use subtitles? And the simple reason is that we do not have subtitles for essentially all of the video data in our corpus. We developed a supervised machine learning approach for ASR, which requires a huge amount of manually transcribed audio speeches in order to learn, to train the model. This is the biggest problem that we have at the moment because there's only one significantly large corpus we're aware of, which is in English, so our ASR currently is limited to English. We use, the model that we're using uses the Libre speech corpus, which is about 1,000 hours of audiobook recordings manually transcribed. And the acoustic model that we use translates utterances into individual letters, and we train a language model on top of it, which is currently based on the DBpedia abstracts, and this one aggregates individual letters to words based on a probable letter co-occurrences. I can show you a quick example if the sound is working by now. I'm not sure it is. Let's see. I can hear it. So, so below is the transcription, and on top you see the film. But yeah, well, it doesn't matter. The most essential take-home message here is that it works quite all right for example, the financial terms. It doesn't work quite well for colloquial chit-chat, which is mainly based on the fact, we believe this is mainly based on the fact that we're training the language model on Wikipedia, which does not contain so much chit-chat compared to, for example, financial terms. Okay, so this already brings me to the end of my talk. Yeah, thank you very much for your attention, and I'm happy to answer your questions.
Does anyone have a question? Yes, in the back here.
Cheers. Thank you for your talk. Are you aware of the Mozilla Common Voice project?
Yeah.
Okay, great.
Thank you. But they're doing a great job. The problem is still that the languages which are not English are too small, so the representation of the volume of data is still too small. We're looking into this every now and then, and we hope that they manage to increase their data, and if that happens, then we'll...
You probably cannot contribute your transcribed data to them for copyright reasons, I guess.
You mean for English? I'm not, so it could be that we have a copyright issue here. I'm not sure about this. The problem is that I'm not necessarily sure that this would help them a lot, because our ASR still makes mistakes, and in order to train a model, you want to have perfectly aligned and perfectly transcribed data. Otherwise, everyone else who's using the data would learn our errors. So this is nothing which they would necessarily want to.
Another question? No? Thank you. This is fascinating. The similarities between this and other kinds of classification are quite apparent. So thank you for this.
Thank you.